Guys, welcome to my channel. Today we'll see how binary search works. So before going for binary searching, we'll see what is searching is. So searching is the process of finding particular key element in the given list of elements, and the searching is successful if the element is found, otherwise it is unsuccessful. As you can see, let us say this is one list where we try to find element 31. Okay, so searching is the process which is used to find the location of a key element in the list of elements. Searching algorithms, we have two different searching algorithms. One is called linear search and the other is called binary search. So today in this lecture particularly we'll see what is binary searching is. So let's begin with the binary search. So binary search is one of the fastest searching algorithms, and it is used for finding the location of an element in a linear array, and it works on the principle of divide and conquer technique. So what is divide and conquer? That we keep on dividing the given list into sublist of sub arrays, finding the mid value and again dividing the sub array. So we repeat the procedure, and that is called divide and conquer. Here very important thing is this binary searching algorithm can only be applied on sorted arrays. So to apply binary search, the array should be sorted, the list should be sorted. So if the list is not sorted, the array is not sorted, the first thing you have to do is you have to first sort it and then apply binary searching. So let's start. So as you can see in this diagram, we have taken the same list, right? So where there are 10 different elements and these elements are sorted. Very important, these elements are sorted. The elements, the beginning index is 0 and the last index is 9. So this beginning index we call it now low, and the last index we call it as now high. So first we'll determine or we'll find the mid value by applying this formula, mid equal to low plus high divided by 2. So in this case low is 0 and high is 9. So it becomes 0 plus 9 divided by 2 equal to 4. So 4 is the mid value. The value at mid is 27. 4 is the index of the mid element, right? And the value at the mid element is 27. Let us assume that the key value, that is the value being searched, is 31. Like we are trying to find element 31. So we compare the value stored at location mid, which is 4, with the value being searched, which is the key value 31. It means we are comparing 27 and 31, and we find that the values are not equal, not matching. Next thing we do is we try to find whether this key value is greater than the mid value or it is lower than the greater value. So in this case the key value 31 is greater than the key value, right? Greater than the mid value, right? 31 is greater than the mid value. What it means is it must present in the right sub array, because our array is sorted, right? Since it is sorted, the key value 31 must be present in the right sub array, as you can see in the diagram. Okay, if the key value is lower, it must be present in the left sub array. So in our case the 31 is present in the upper half of the array. Now this upper half is the new list for us. Now we are going to work on it now only at the upper half. Okay, so for the upper half again we have to repeat the same procedure. Again we'll find mid, again we'll compare values like that. But now the low value in this case now will change. Okay, the low value is the element which is next to the mid element, right? The mid element ka index was 4. The next value ka index should be 4 plus 1, which is 5. It means what? For the new low it will be mid plus 1, which is 4 plus 1 equal to 5. So 5 is the new low now, and high remains same, which is 9. The new mid will be 5 plus 9 divided by 2, which is 7. So element at 7 is 35, so which is the mid element now, right? Now this mid element will again compare with the key element, which is 31. So 35 and 31 not matching, right? So what next we do? We find whether this 31 is greater than the mid value 35 or it is lesser than the mid value 35. So in this case 31 is lesser than 35, which is the mid value. It means what? Our key element is present in the lower subpart, right? Lower subarray. So as highlighted here, this is the lower subarray, right? Again we have to repeat the procedure. So we have this subarray now. So again we'll repeat the same procedure, means again find the low, high and mid. So in this case, since this is the lower sub half, now the high will change, right? Low remains the same, which is 5. High is what? High is the one less than the mid, right? Our mid was 7, right? Before 7 element, which must be mid minus 1. So it is 7 minus 1 equal to 6. The new mid becomes 5 plus 6 divided by 2, which is 5. Okay, so we got mid 5. Again we'll compare the key value with the value at mid, which is 5. The key value is 31. Value at mid 5 is 31. Both are matching, means value to be searched and value at mid are matching. We found the element at location 5, right? We got element 31 at location 5. Okay, this is how it works, right? So whatever we have seen, we can just put it into steps that will give you binary search algorithm. Okay, the very first thing we did, we find mid, right? And then compare mid element with the key element. If they are matching, the key element is found. If they are not matching, we find whether the key element is greater than or lesser than the mid value. If it is greater, we again search in the right subarray, but if it is lower, we search in the left subarray, and we keep repeating this process, means steps 1, 2 and 3. Keep repeating until the size of the subarray becomes 1. Means what? There is only one element in the subarray, right? If the key value does not exist in the array, the algorithm returns an unsuccessful search. Let's see this sample code for binary searching program. This is the main program and this is binary search recursive procedure. Okay, recursive procedure is what? We call the same function in the function itself. Okay, so main function, we are giving the list itself. So 12, 14, 18, 22, 39, these elements are given. First they are giving key value 12 and then key value 23. Then inside the function, first you calculate mid value, which is low plus high divided by 2, and then we try to compare, and accordingly we call the recursive function here, right? Let's see how this runs here, right? It's a binary function. First you calculated the mid value. If low less than equal to high, then we compare mid and the key. If they are same, we just print the mid. If key is less, we search in the left subarray. That is how we pass in the binary function array low, mid minus 1 and key. If the key value is greater than mid, we are called binary searching by passing array mid plus 1, high and key, right? Else if low is greater than high, then unsuccessful search if element is not present in the array. Let's see. Let's compile. So we got element found at index 2, right? Why it is? Because here we are given key element 18, which is at index 2, right? 0, 1, 2. So it is index 2. The next key element given was 23. 23 is not present in the list, so it is giving unsuccessful search. Now let's try and change this key element. Let's take here 12 and again compile and try to run it. See what we got? Element found at index 0. We have given key element 12. Key element 12 is at 0th position, first position. So 0 and 23 again unsuccessful search. That's it guys. I hope you understood how the binary search works. Thank you. See you again.